Hello, good evening. Good evening, all of you. Just confirm once. Audio, video, everything is okay? Good evening, good evening. Wake up. Hi, hello. Audio okay? Yeah, audio, video, okay? Yeah, chalo. So, what we discussed in previous lecture? In previous lecture, we discussed about hello, 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 hello. Yeah. Mohit Sai is saying said about chi. Very good. Mohit Sai, chi is the representation for electronegativity in chemistry. Okay, good. Yeah, it is better to say electronegativity, or we can use chi symbol there, you're knowing. Okay. If you are saying, sir, En, those who are knowing chemistry in a proper way, they will say, sir, En means ethylene diamine. Let's say En is only, this is written En. I will say this is abbreviation for ethylene diamine. Okay, that's why it is better to know the correct representation. To make our life easy, sometimes we are writing this thing for the electronegativity, but this is not the correct abbreviation you are knowing. For the electronegativity, correct abbreviation is chi. Okay. Answer few things before we start the today's discussion. I want to know that how much you learned from the previous lecture. I will ask few questions here. Can I say that En of atom, any particular element, is affected by the atoms to which it is bonded, in surrounding atoms? Let's say any atom is there, any atom I can take, for example, nitrogen is there. Now it is bonded with the oxygen, or nitrogen is bonded with the hydrogen. Here En is affected or not? Yes or no? Yes, yes. Means I can say electronegativity is affected by the atom to which it is bonded. Am I right? Yeah, very good. Very good. Chalo, answer one more thing. In case of Pauling's scale, En of fluorine, we are saying 4. This 4 is measured value of electronegativity, or it is assigned value of electronegativity. Everyone is knowing in Pauling's scale, electronegativity of fluorine is a 4. Everyone is knowing. But what chemistry people must be knowing in better way with the proper concept that I am trying to ask here. In case of fluorine, electronegativity is 4. This is given by the examiner. Now my question is, this 4 is measured value or assigned value? Assigned. Sharad Chandra is saying measured. Then assigned. One more. Sharad Chandra again saying measured. Same person. Sharad Chandra, have you attended previous lecture? Sharad Chandra, have you attended previous lecture? Saran Chandra, I'm asking to you, reply quickly. Have you attended previous lecture? Because you are the only person who is saying measured. All are saying assigned. Or they are saying not measured. Yeah. Sarat Chandra, reply bro. One more student is saying, Pavan Kumar is saying measured. No. This value is arbitrarily assigned value. Electronegativity cannot be measured. Sarat Chandra is saying no. Means he didn't attend the previous lecture. Okay, that's why you are giving wrong answer, bro. What is the important point here? What we are learning here? Don't memorize the values, understand the meaning, understand the significance. Because kind of paper, kind of questions they are asking, don't expect they will ask what is the EN of fluorine. Don't expect. Don't expect in competitive exams they will ask what is the EN value of fluorine in Pauling's scale. Expect this kind of question, EN of fluorine is 4. This is given. This 4 is, they can give 4 options. Assigned value, measured value, or 2 more options they can create. So answer is, this is assigned value, not measured. EN cannot be measured. Electronegativity cannot be measured. Okay? Chalo. So 99.999% students answered correct, assigned, and only one student said measured, and I don't think it is the mistake in this part because he didn't attend the lecture. Okay, no problem. Sarat Chandra, you understood? Yeah. Chalo. Okay. Next, I will ask one more question here. Let's say I want to say electronegativity of carbon. I can take any other atom also. Let's say I want to say about the electronegativity of carbon. So can I say it is a fixed? Can I say it is a fixed value? Can I say electronegativity of carbon or any element is a fixed value? Yes or no? No. Very good. Yes, we cannot say. Because electronegativity of any element is not constant. Okay. We discussed in previous lecture for sp3 carbon, electronegativity is approximately 2.5, sp2 carbon approximately 2.75, and sp carbon approximately 3.25. Chalo, very good. Chalo. Now, one more question here. Tell me one thing. Electronegativity of carbon in CH4 molecule and in CF4 molecule, EN of carbon, electronegativity of carbon in CH4 molecule and in CF4 molecule are same or different. Both the cases it is sp3 carbon. So EN values of carbon in CH4 and CF4, are they same or they are different? Different, not same, different, very good. Means you learn concepts in previous lecture in a proper way. Because this kind of question coming in the exam, I can guarantee 99% students are going to give wrong answer. They will say, sir, both are same. Both are sp3 carbon. Both are sp3 carbon. But values are not exactly same because surrounding atoms or atom to which carbon is bonded, they are not same. Very good. I am impressed. Chalo, one more question. Tell me one thing, electronegativity of carbon and chlorine are exactly same. Statement is true or false? Electronegativity of nitrogen and chlorine are exactly same. True or false? Yeah, approximately same. Very good. En of nitrogen and chlorine are approximately equal. Approximately equal, not exactly equal. Electronegativity symbol chi of nitrogen and chlorine are approximately equal, not exactly equal. Chalo, very good. So now answer one thing. Out of NaCl, who is having slightly more En value? In reality, out of nitrogen and chlorine, who is having slightly more value? Chlorine, 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 chlorine. One person said nitrogen, then one more said, Ruchita said nitrogen, others are saying chlorine. Yeah. Again, 99.99999% public saying chlorine. Yeah, very good. 3.2 and nitrogen is 3. So today, in previous lecture, I said I will discuss one very good question. So today I will start, before going the detail of the next topic, I will start today's discussion from this concept, En of chlorine versus nitrogen. En of chlorine is slightly more than nitrogen. Sir, why it is important? Why it is important? Because if you read, this symbol represent electronegativity. Those who joined just now, for them I am saying this symbol representing electronegativity. Okay. So why this discussion is important? En of chlorine is slightly more than the En of nitrogen. Why this discussion is important? Because if you read your periodic table NCERT, in periodic table NCERT, they are writing 3 and 3 for both. So in periodic table, they are saying 3 and 3 both. Periodic table NCERT. And if you read your P block NCERT, here they are saying 3 for nitrogen and 3.2 for chlorine. And I will say in both the cases NCERT is true. So how it is possible? 3, 3, one case, another case 3 and 3.2. And I am saying in both the cases NCERT is correct. Sir, how it is possible? So in periodic table NCERT, when they are writing the values, they are giving one disclaimer. Listen carefully. In periodic table, when they are writing electronegativity values, they are giving one small disclaimer कि whatever values are given, they are approximate values. Listen, you'll get the concept. When they are writing these values in periodic table part of the NCERT, they are writing 3 and 3. In P block, they are saying 3 and 3.2. And what I am saying, in both the cases NCERT can justify I am correct. Because when they are saying in periodic table, when they are saying this thing in periodic table, they are saying approximate values are given in that table here. So when they are saying approx values are given, it's approximately 3, 3 correct na yaar. And when they are writing values in P block, they are not giving any disclaimer. So in both the cases NCERT can justify I am correct. Okay or not? So if examiner is asking this type of statement, electronegativity of nitrogen and chlorine are exactly equal, then you have to say this is false. If they use term exactly equal, then you have to say false. Got the concept? Now the best part is in NCERT exampler we have, I will show both of them, don't worry. And in NCERT examiner we have very beautiful question there. So before going the detail of today's discussion, I'll go for the few important points given in the NCERT. Let's check one by one. This is NCERT of periodic table. Just wait. Yeah. See, in periodic table NCERT, you can check. For nitrogen, they are writing 3. For chlorine also, they are writing 3. And they can justify by saying this thing, ki here I gave one disclaimer. By this line, approximate values for the electronegativity of few elements are given in table number 3.8. So if we say this is wrong, then we say no. When I said they are exact values, I gave disclaimer they are approximate values. If you are considering them as the exact value, this is your fault. Got it? So here NCERT is saying approximate values of electronegativity given in table number 3.8a, and this is the table number 3.8a, where they are giving 3 and 3. Chalo theek, nitrogen 3, chlorine 3. Now move to the P block. Move to the P block. Now see, in P block, see, for nitrogen, electronegativity value is given for nitrogen 3.0. Okay, you can check it here. Electronegativity of nitrogen written 3.0. And when you are going to the group number 17, just wait. Group number 17, see, electronegativity of chlorine, what they are writing 3.2. And observe, when they are adding electronegativity value here, electronegativity, what they are writing here, B. B means Pauling scale. B means Pauling scale. Getting or not? So here they are saying electronegativity of chlorine is 3.2. Okay or not? This part is done. Now the most important thing is, here we have one question also in NCERT exemplar based on this concept. Check this question. In NCERT exemplar we have one question based on this concept. I think question number 37. Let me check. 1 minute. No. This one. Question number 23. Here, what is given there? A black compound of manganese reacted with the halogen acid to give greenish yellow gas. When excess of this gas reacted with NH3, unstable trihalide is formed. In this process, oxidation state of nitrogen changes from. So I will emphasize on this part for now. Greenish yellow gas which is formed is chlorine. So when NH3 reacts with the excess of chlorine, all hydrogens are replaced by chlorine, and what I will get there? NCl3. What I will get here? NCl3. I'm not balancing the reaction, I'm emphasizing on the important part here. Now what question they are asking? In this process, oxidation state of nitrogen changes from. And check the options. They are giving -3 to +3, -3 to 0. This kind of options given. So tell me one thing. Out of nitrogen and hydrogen, who is more electronegative? Out of nitrogen and hydrogen, who is more electronegative? Out of N and H, who is more electronegative? N, obviously. So I will assume nitrogen oxidation state X, hydrogen plus 1, so 3 hydrogens plus 3 is equal to 0. So X is equal to minus 3. Means in case of NH3, oxidation state of nitrogen is minus 3. Okay or not? Now go to the NCl3. If you are thinking that EN of nitrogen and chlorine are exactly equal, let's say you're not knowing the chemistry, let's say you're not knowing the concept, or let's say you mug up the data of NCERT periodic table only, you didn't follow the concept, then you will say, sir, N and Cl have same EN, so since they have same electronegativity, oxidation state of nitrogen is 0, and you will take second option. But in reality, out of nitrogen and chlorine, who is having more electronegativity? Tell me please, out of N and Cl, in reality, actually, who is having more electronegativity? Please answer. Chlorine. Yes, very good. So here, chlorine is more En, so chlorine is going to acquire minus charge. So I will say X for nitrogen. Chlorine is more En, so will acquire minus charge. 3 chlorines, I will write minus 3 is equal to 0. Here X is going to be plus 3. So N is here plus 3. So oxidation state is changing from minus 3 to plus 3 here. Changing from minus 3 to plus 3. And to check your knowledge, to check your concept, they gave this option also minus 3 to 0. And to create confusion, they are giving one more option 0 to minus 3. But actual answer is minus 3 to plus 3. Logic is clear? So this kind of clarity I am talking about. And that will get here only. Because other places they will say NCl33 given in the periodic table, story over. But we are going in minute details also. What they are saying in periodic table, what they are saying in P block, what question they are asking in exemplar. We are planning in this way for each and every topic. Someone said in the comment few minutes back, each and every line of NCERT is important. When I was saying that NCERT or periodic table, they are saying approximate values given. This type of study is required, and that will get here only. Question number 23. Question number 23 we solved. What answer given here? See, first option. Question number 23, what answer given here? First option. Getting or not? What answer given? First option. Means in this much detail NCERT is going. We are not realizing, because many times we are reading superficially only. If you want to go for superficial knowledge, better to go for board exam only, that's all. If you want to go for NEET type of examinations, where they are asking concepts, where they are checking your knowledge, you have to go in right hands. You have to take right decisions. And this is not the only one point which I am saying. This is happening every day in class, where we are emphasizing what NCERT is saying in this chapter, what NCERT is saying in another chapter, what example they are giving exemplar. We are covering all the aspects. Okay. So got the concept or not? Got the concept or not? Yes or no? Chalo. Very good. So you got the clarity about the electronegativity. Am I right? Yes? Yes, very good. Chalo. So now today we'll discuss next topic. Next topic, that is hybridization. Today's topic is Mansoor Basha is saying I got clarity about the NCRT. Good. Good. This is just a small thing. What small thing we are giving here? Okay, one drop of the ocean, you can say. Ocean of the three Gosalites. Okay. Chalo. Yeah. So new topic is hybridization. Okay, I will start from the question. Sir, you are here to teach, then why you are asking question? By asking question, we are able to figure out from what basic we have to start. As I promised in the previous lecture, we are starting from basic and uplifting you to the infinite level based on the syllabus. Okay, chalo, very good. Okay, so now I will start from one question. You are knowing hybridization means intermixing of the atomic orbitals. Am I right? Intermixing of atomic orbitals. Everyone is knowing? Yes or no? Intermixing of atomic orbitals. I will ask one simple question. Hybridization is intermixing of atomic orbitals of, first option, same atom, second option, different atoms. Question is clear? Hybridization is intermixing of atomic orbitals of same atom or different atoms. Same, different, both, different, same, energy. Energy we'll discuss later. I'm asking only same atom, different atom. Intermixing of atomic orbitals of same or different. Different, both. It cannot be both here. Different, same. Okay. Okay. Same, both, different. Okay. No problem. Listen. Hybridization is intermixing of atomic orbitals of nearly equal energies related with the same atom. Same atom. So I will go in the detail now. That's why I said I will start from the question, then I will uplift you from the basics. So what basic is, first of all, before going the detail of hybridization, we need to know the difference between overlapping and hybridization. We have to understand difference between overlapping and hybridization, then clarity will come. So in case of overlapping atomic orbitals, it may be hybrid orbitals also, just for now I am taking atomic orbitals for ease of explanation. When atomic orbitals, or it may be hybrid orbitals also, of different atoms are combining, this is known as overlapping. For example, let's say we have atom 1 and this is atom 2. Atom 1 is providing some orbital, maybe S, maybe P, maybe D, or maybe hybrid orbital SP, sp2, like that. So atom 1 is providing some orbital, let's say S orbital. For example, let's say 2s orbital. And atom 2 is providing orbital, it may be 2s, it may be 2p, it may be another orbital. So assume atom 1 is providing 2s orbital, atom 2 is providing 2s orbital, and they are combining. It may be another orbital also, it may be 2p, 2p also. So when these two atomic orbitals of different atoms, atom 1, atom 2, are going to combine, this is the nucleus of first, this is the nucleus of second atom. They are going to combine, they will combine here in this way. Nucleus of first, nucleus of second. So you can check, two nucleuses are there. This is also proving that this 2s and this 2s, they belong to the different atoms. This process or this phenomena is overlapping. Okay or not? While in case of hybridization, atomic orbitals of same atom are going to intermix. For example, assume we have 2s orbital of some atom, 2s orbital of any atom, and 2p orbital of same atom, 2s and 2p. It may be other orbital also. I am taking 2s, 2p just for explanation. So here you can check, both 2s and 2p are related with the same nucleus. So 2s orbital and 2p orbital of same atom are going for the intermixing, and they will give you hybrid orbitals. This phenomena is hybridization. Logic is clear or not? So when atomic orbitals, or maybe hybrid orbitals also sometimes, or in fact large number of cases, so when atomic orbitals or hybrid orbitals of different atoms are going to combine, this is overlapping. And when atomic orbitals of same atom, like 2s of some atom and 2p of the same, are going to intermix, this is known as hybridization in chemistry. Logic is clear or not? And now you will say, sir, is it given in NCERT? Yes, it is given in NCERT. This thing is given in NCERT. Wait, I'll show you. Yeah. Now see, when they are explaining overlapping, what they have taken? Atomic orbitals of different atoms. See, when they are explaining overlapping concept, they have taken atomic orbitals of different atoms, like pp of different, s and p of different. This is, by this they are explaining overlapping. And when they are going to explain hybridization concept, we can check it here. What diagram they have drawn? See, this black is 2s orbital, this black one is 2s orbital, this one blue one, this one, let's say 2px, then this is 2py. So by this diagram, what they are explaining or what they are emphasizing, they are emphasizing for the hybridization purpose, whatever atomic orbitals are used, they are belonging to the same atom. Got the concept or not? Sir, why it is important? If I say intermixing of atomic orbitals is hybridization, This much knowledge, those students are also having who are preparing only for their board exams. But extended part is atomic orbitals of nearly same energies, and the more important part is belonging to same atom are intermixing or combining. This is hybridization. Definition is clear to you or not? Definition is clear to you or not? Understood the definition? Definition is clear? Yeah. Chalo. Okay. So what I said here, intermixing of atomic orbitals of nearly equal energies related with the same atom is hybridization. Now next part is how hybridization is going to help to gain the stability in case of molecules. See, whatever is happening in the molecules or in the atoms, they are trying to increase their stability. Yeah, am I right? Now point is how hybridization will help to increase the stability. So answer is hybridization will increase the stability by minimizing the repulsion. This much information or knowledge you have, if repulsion is less, stability is more. Am I right or not? If repulsion is less, stability is more. In a family, let's say two families are there, family 1, family 2. In family 1, members are fighting a lot. Anytime you go there, they are fighting. Huge repulsion. Another case, another family, they are fighting sometimes. Mostly they are happily living together with love and attraction. Which family is stable? Obviously, second one is stable here. So if repulsion is more, stability is less. Am I right or not? So hybridization is actually minimizing the repulsion. How it is minimizing, that also we'll discuss. Okay. So what hybridization is doing? Hybridization is minimizing the repulsion. And by minimizing the repulsion, it is increasing the stability of molecules. Got the concept? Now next part is, sir, how hybridization will minimize the repulsion? So that we'll discuss by the examples, don't worry. For that I need to take first example here, that is sp hybridization. sp hybridization. Okay, tell me one thing. Have you realized when you're writing overlapping or writing like this, let's say this overlapping between S and P, you will say, sir, sp overlapping in this way. Let's say overlapping is taking place between S and P orbitals, you will say, sir, sp overlapping. But when you're writing hybridization, you're not using this hyphen, you're writing sp hybridization. Have you realized why? Definition is giving answer here. In overlapping, whatever orbitals are used, they are related with the different atoms. And that's why to segregate them, we have to use hyphen there. But in case of hybridization, whatever atomic orbitals are used, they are belonging to the same atom. That's why we cannot use hyphen there, or there is no need to represent the segregation. Okay, so representation is also telling you a lot, just you have to analyze it. Okay, so first topic is here sp hybridization. First topic is here sp hybridization. So now, if I want to write sp hybridization, what I will use? I will use s orbital and p orbital. And you're knowing s orbital is spherical, p orbital is dumbbell, that you're knowing. So this is 2s orbital, assume it is 2s orbital. So I will take here 2p orbital. Sir, why 2p? Why not 3p? Sir, why 2p or why not 3p? So in the definition part, I said one point. In case of hybridization, atomic orbitals of nearly same energies are going to intermix. Right? They are 2s and 2p. The energies cannot be equal provided it is not one electron species. So the energies are not exactly equal because 2s 2p they are not having same energies, you are knowing. Only one electron species is there, then only they can have equal value, otherwise no. So exactly equal energy is not possible for 2s 2p except one electron species. But if it is 2s and 2p, their energies are approximately equal. But if it is, let's say, 2s and 3p, their energies are not approximately equal. There is a large difference in the energies for 2s and 3p. That is why when I am writing hybridization here, if I am using 2s orbital, I will take 2p orbital. It may be 2px, 2py, 2pz. Oftenly we are taking z here. Okay or not? The logic is clear. If I am writing 2s, why I have taken 2p? If I have taken 2s, why I have taken 2p? This is clear to you or not? Okay, because they have nearly same energies. So energy of E means energy of 2s and 2p I will take nearly same, and that is why I am representing them here. And why I am representing this way? Because 2s and 2p must be belonging to the same atom. Now these orbitals are going to intermix. These orbitals are going for intermixing or mixing, simply you can say. Okay? And they will give you hybrid orbital. Now in case of hybridization, one very beautiful part is there. In case of hybridization, if you have taken two atomic orbitals, two AOs are there, atomic orbitals are there, they will give you two hybrid orbitals. If you have taken three, then you will get three hybrid orbitals. So I can generalize, if I have taken n atomic orbitals, I will get n hybrid orbitals. If I am taking n atomic orbitals, I will get n hybrid orbitals. 2 atomic orbitals, 2 hybrid orbitals. 3 atomic orbitals, 3 hybrid orbitals. 4 atomic orbitals, 4 hybrid orbitals. Means whatever number of atomic orbitals are present before hybridization, same number of hybrid orbitals will come after the hybridization. Okay or not? So here, in case of sp hybridization, how many atomic orbitals are taken? Atomic orbitals means orbitals of the atom. So how many atomic orbitals are taken in case of sp hybridization? 2, obviously. One is 2s and another is 2p. 2 are taken. Name is also giving answer. Name is sp hybridization. S and p. 1s and 1p. So total orbital count is 2. If I have taken 2 atomic orbitals for the hybridization purpose, how many hybrid orbitals I will get? If I have taken 2 atomic orbitals, how many hybrid orbitals I will get? Please answer. 2. Obviously 2 hybrid orbitals will get. Now point is how to place them. Before that, one more thing. If I represent electron density of one hybrid orbital, it is represented like this, where we have one big lobe and one small lobe. Big lobe is having plus sign and this small lobe is minus sign. Here plus minus sign is not related with the charge. This plus minus sign is not related with the charge. It is related with the amplitude of wave. Like you're writing sometime like this. So one hybrid orbital means one big lobe, one small lobe, big lobe plus sign, small lobe minus sign. Now answer one thing. Now answer one thing. Here, if I am having two atomic orbitals, video not coming. 1 minute, let me check. Now it is coming. Now coming. Yeah. Now it is coming. Yeah. Chalo, no problem. Okay. So what I was saying, okay, those who missed at the time of some glitch, I'm saying here, I said here, ki in case of one hybrid orbital, I'm not drawing two here, one hybrid orbital can be represented like this, where we have one big lobe, one small lobe, big lobe plus sign, minus sign is given for the smaller lobe. This plus minus don't represent charge, this plus minus represent wave. Okay. So now in this case, if I am going for the sp hybridization, I am having one 2s and one 2p. So total two atomic orbitals are there. So I will get two hybrid orbitals. Two atomic orbitals, so two hybrid orbitals will be there. And what is the purpose of hybridization? To minimize the repulsion. Hybridization is taking place to minimize the repulsion, so stability can be gained. This is also given in the NCERT. So now tell me one thing. Let's say you have two objects which can repel each other. Two objects. Why I am saying two here? Because in this case, two atomic orbitals will give two hybrid orbitals. So let's say I have two objects which are repelling each other. Object number 1, object number 2, and they have tendency to repel each other. And you want minimum repulsion. Where you will keep them, at what angle you will keep them? You will keep them like this, at the maximum possible distance. So they will have minimum repulsion. That is 180-degree angle here. Logic is clear or not? Purpose, go for the purpose. Why hybridization taking place? To minimize the repulsion. Now here how many hybrid orbitals form? Two hybrid orbitals are going to form. So I said simple analogy. Let's say we have two objects, object number 1, object number 2. They have tendency to repel each other, and I want to minimize the repulsion between them. I want minimum repulsion between them. Then I will keep them at the maximum possible distance, and that I will get at 180-degree like this. Got the concept? So that is why here two hybrid orbitals. This is hybrid orbital, let's say number 1. Small lobe minus, big lobe plus sign. This is one hybrid orbital. Another hybrid orbital I will represent by some other color so you can easily identify. Another hybrid orbital is this. Small lobe minus, big lobe plus. These are two hybrid orbitals. So actually in this case, this is sp hybrid and this is another sp hybrid. You can check two sp hybrid orbitals are there. Two sp hybrid orbitals are there. One is drawn by yellow and another is drawn by green for the easier identification. Okay or not? So here, why I kept them in this way? One is pointing left, so other is pointing right. So they can minimize the repulsion. And because of this, this angle is going to be 180-degree. So let's say we have molecule where A is the central atom, which is going for sp hybridization, and B are the surrounding atoms. If A is sp hybridized, this angle is going to be 180 degrees. Okay or not? So repulsion become minimum. So you got the idea what I was saying? Hybridization is minimizing the repulsion. Okay, that's all. Now sp hybridization is also named as diagonal hybridization. sp hybridization is also named as diagonal hybridization. sp hybridization is also named as diagonal hybridization. This is also given in the NCERT. Sir, why this name is given? See, if you want to learn the concept, you have to go for this type of questions. Sir, why, how, what is the reason, like that. So this sp hybridization is named as diagonal hybridization. Now question is why. So assume this is a sphere. So this is circle. In 2D I can represent a sphere like circle layer. Okay. So assume this is a sphere. And I will draw 2 points. Let's say point number 1 and point number 2 passing through the center. So this become diagonal, and this is giving me linear arrangement. So I will assume this point as atom B, this point as atom B. So this, and this is central atom A. This angle is going to be 180. So this linear arrangement I can get by keeping surrounding atoms in the diagonal position, and obviously central atom kept at the center. So I'll get this thing. And that is why this sp hybridization is also named as diagonal hybridization. Okay or not? So here many questions are possible. First question, simple question. In case of sp hybridization, 2s s and p orbitals, whatever s and p orbitals are used, they are having same energies, exactly same energy or nearly same energies, obviously nearly same energies. They belong to same atom or different atom, so obviously same atom. They will give how many hybrid orbitals? 2 hybrid orbitals. These hybrid orbitals are present at the maximum possible distance to minimize the repulsion. That angle is 180 degree. Okay or not? And in case of sp hybridization, if it is 2s and 2p, so I am writing like this: 2s and 2p are going for sp hybridization. Then I will write like this: 2sp. So what is the meaning of this? This 2sp is the name of hybrid orbital, and this 2 is representing number of hybrid orbitals. Sir, why it is so? So I will take another example, then better clarity will come. Let's say this is 3s and 3p. 3s and 3p. They are going for hybridization. So 3s and 3p are used. So name of hybrid orbital will be 3sp. And number, so 2 atomic orbitals. So 2 hybrid orbital, number is going to be 2. So in the second case, this 2 is representing number of hybrid orbitals, and this 3sp is representing name of hybrid orbital. So what I can generalize, assume ns and np, where n is the principal quantum number, ns and np orbitals, let's say npz, are going for hybridization. Then I will write this as a 2nsp. Here this nsp represent name of hybrid orbital, and this 2 represent number of hybrid orbital. Got the concept or not? So in this previous discussion, what I took here, 2s and 2p. What I took here, 2s and 2p. Since I have taken here 2s and 2p, name of hybrid orbital will be 2sp, and next hybrid orbital is also going to be 2sp. This next hybrid orbital is also going to be 2sp. Name is 2sp. Name of hybrid orbital is 2sp. And number 2 in this case. Logic is clear. Now, one very important concept. In previous lecture, I said you one simple calculation. In case of sp hybridization, percentage S character is 1 by 2 multiplied by 100 is equal to 50%. This we discussed in previous lecture only. In case of sp hybridization, percentage S character is equal to 50%. Am I right or not? Percentage S character is 50% for sp hybridization. That's what we discussed in previous lecture. Now go to this detail. Here I have drawn sp orbitals. How many sp orbitals you can observe here? 2 obviously. So actual calculation is for this sp hybrid orbital, yellow one, percentage S character is going to be 50%. And for this sp, because it is also sp, so 1 by 2 into 100. So for this also percentage S is going to be 50%. So what beautiful question examiner may ask here, and directly from the NCERT. In case of sp hybridization, 50% S character is present for each hybrid orbital. True or false? This is statement given. In case of sp hybridization, 50% S character is present for each hybrid orbital. True or false? In case of sp, answer quickly. In case of sp hybridization, 50% S character is present for the each hybrid orbital. True or false? True. Very good. Understood the concept or not? This kind of clarity I am talking about. Because tell me one thing. If I ask this question, what is the percentage of S character in sp? Everyone is knowing here. Everyone is knowing 50%. But if I give this kind of a statement, in case of sp hybridization, 50% S character is present for each hybrid orbital, 50% S character present for one hybrid orbital, like that, then unnecessarily confusion will happen if you're not knowing the concept. Okay, got the concept or not? So for sp, what we discussed, let's summarize quickly, then move to the next one. sp hybridization, what we discussed here, it is named as diagonal hybridization. Here bond angle is 180 degrees. It is having percentage S character is equal to 50% for each hybrid orbital, and diagram everything you are knowing. Let's move to the next one. Before that we'll observe the NCERT. Here. sp hybridization, this heading is written there. You can check it. This type of hybridization involved the mixing of one s and one p orbital, resulting in the formation of two equivalent sp hybrid orbitals. The suitable orbitals for sp hybridization are s and pz. I said usually we are taking pz. If hybrid orbitals are to lie along the z-axis, each sp, read this statement, each sp hybrid orbitals has 50% s character, so obviously p character is also going to be 50%. What line they are saying? They are not saying directly sp is having 50% s character. Each sp hybrid orbitals has 50% s character and 50% p character. Okay or not? Move to the next part. Such a molecule linked indirectly to the other central atom possesses linear geometry. This is also discussed. This type of hybridization is also known as diagonal hybridization. This type of hybridization is also known as diagonal hybridization. Then I said about the diagram and everything, plus and minus sign. This is also given in NCERT. Read this thing. The two sp hybrids point in the opposite direction along the z-axis with the projecting positive lobes and very small negative lobes. Now talking about this diagram, what we draw earlier. Ki big lobes are opposite at 1 degree and we have two very small lobes with the minus sign. They are two sp hybrid orbitals. So this also point is written there in the NCERT. So sp part is done. sp hybridization is done. If you have any doubt in the sp hybridization, ask. Otherwise I will move to the next one. Any doubt is there in the sp hybridization, then ask. If anyone is having a single doubt in the sp hybridization, ask your doubts here. No doubt. Very good. Chalo. Chalo. Very good. Last statement, which one? Percentage character. That one. 50%. In case of SP, how many hybrid will come? In case of SP, how many hybrid orbitals will come? 2. For this, how many S? 1 and P. So percentage S will be 50. For this also percentage S is 50. So each has 50% S, 50% P. 50% S, 50% P. Okay. Okay. Got it? Okay. Sandeep, you got the concept? Yeah. Chalo. Yeah. Yeah, name is 2sp. Chalo. Next is very good, very good. Chalo, next one. Next is sp2 hybridization. Why this kind of information required? See, for others, SP means linear geometry, story over. For me, teaching linear is useless thing. Because that is known by everyone else. If this question is coming, SP is linear, this is not going to create a difference between knowledgeable student and average or below average student. If you are going the detail, this will create difference between average student and topper kind of student. That's why we are teaching in this way. Next is SP2. SP2. Now you have to answer. For SP2, let's say I have taken 2s orbital. Let's say I have taken 2s orbital. Then what I will take here? Can I take 3p orbital? Can I take 3p orbital? Knowing first SP will take time. Remaining you have to answer quickly. Because now knowing concepts you can analyze. You can apply your own. This is the importance of concept. If you knowing concept, you can solve unknown problems also. So let's say I have taken here 2s. Can I take 3p here? No, I have to take 2p. How many 2p required? So name is the answer. Name is SP2. SP2. How many p required? 2p orbitals are required. For example, 2px and 2py. Because I have to take atomic orbitals of nearly equal energies. Chalo, this part is done. Now answer one thing. Let's say I want to represent these three orbitals before hybridization. What is a better representation? One case where I am representing all three having same nucleus or representing differently. So obviously same nahi, because they belong to same atom. So here, let's say I have drawn a 2s like this. This is a 2s. This is 2s. So now I will represent 2px for same one. So I will write 2px like this. Let's say this is 2px and this is 2py. I can represent sign convention also. This is a part of atomic structure, but okay, I will write here. In case of p orbital, one lobe is plus and the lobe is minus. Plus minus sign don't represent charge. That you are knowing. So let's say this is plus, so this is minus. Likewise for this another p orbital also, one lobe is plus and the lobe is minus. In case of s orbital, I can use either plus sign or minus sign. It is my choice. So I'm using one of them, let's say plus. So these are the atomic orbitals before hybridization. Okay or not? These are the atomic orbitals before hybridization. You can observe from this picture clearly that they belong to same atom. This is based on the basic fundamental definition of the hybridization. Okay or not? Now they are going for intermixing, or I can simply write mixing, or let's say chalo, intermixing, no problem. When they are going for the mixing, what they will produce? So how many s orbital present here? One s orbital is present. How many p orbitals are present here? Two p orbitals are present. One is 2px and another is 2py. So one s orbital and two p orbitals. So they will produce sp2 hybrid orbital. Or better to say, they will produce two sp2 hybrid orbital. The name is 2sp2. Name is 2sp2. Why 2sp2? Please answer. Why name is 2sp2? Why name is 2sp2? Answer quickly. Why name is 2sp2? Answer quickly. Why this name is 2sp2? Why name is 2sp2? Why in this example name of hybrid orbital is 2sp2? Yeah, because we took very good. Punanjali, Bhanu, Vishnu, Mallikarjun. Okay, chalo, very good. Sheikh. Okay, very good. Chalo. Because we have taken 2s and 2p orbitals. Because we have taken 2s and 2p orbitals, name become 2sp2. We have taken 2p orbitals and one 2s orbital. So overall we can say name become 2sp2. How many 2sp2 will form? How many 2sp2 will form? Answer please. How many 2sp2 hybrid orbitals are going to form? 1, 2, 3, 4 infinite. Please answer. 1 or 2 or 3 or 4 or infinite. 3, 3, 3, 3, 3, 3, 3. Very good. So I will finally write like this. 3 2sp2. Harika, why you are saying 2? How many atomic orbitals taken here? 3, 2s, 2px, 2py. We have taken 3 atomic orbitals, we will get 3 hybrid orbitals. So here, this 3 represent number of hybrid orbitals. Number of hybrid orbitals. This 2sp2 represent name and this represent number of hybrid orbitals. This part is done. Now next part is how to arrange these 3 hybrid orbitals. So go for the main purpose of hybridization. Purpose of hybridization is to minimize the repulsion. Purpose of hybridization is minimize the repulsion. Getting or not? So here we'll apply small concept of the physics. Tell me, if you have 3 vectors of equal magnitude, let's say f. We have 3 vectors of equal magnitude f. Let's say force vector. I have 3 vectors of equal magnitude and I want 0 net force. What to do there? So if I am keeping 3 vectors of equal magnitude, if I am keeping three vectors of equal magnitude at 120 degree, if I am keeping three vectors of equal magnitude at 120 degree angle, F net vector sum is going to be 0. Okay or not? So sir, why this is required here? So now tell me one thing. In case of sp2, what I got? How many hybrid orbitals I got? I got three hybrid orbitals. And I want minimum repulsion between them. Then I will go for this analysis. If I am keeping them at the 120 degree angle, repulsion is going to be minimum. Getting or not? So here what I will do, I will keep three hybrid orbitals at 120 degree angle. So this is sp2 hybrid orbital, let's say first one. Total three are there, assume this is first one. This is sp2, or as per our example, 2 sp2 hybrid orbital. How many sp2 form? 3. Big lobe plus, small lobe minus. Here also I will use different colors, so you can easily identify different hybrid orbitals. This is sp2 orbital, let's say number 1. This is another sp2 hybrid orbital. This is another sp2 hybrid orbital. And this is third one, sp2 hybrid orbital, big lobe plus, small lobe minus. So in this diagram you can clearly observe three sp2 hybrid orbitals are drawn. For now I am not writing surrounding atom, that also will come, okay. Big lobes are plus, small lobes are minus. And here this angle is 120, this angle is also 120, and this angle is 120 degree. So let's say we have some central atom A and surrounding atoms B are placed at angle 120 degree like this. Then this geometry can be named as a trigonal planar. This can be named as a trigonal planar. You can observe, if I join these three B by hypothetical line, it is making triangle, and all are present in the same plane. This atom A, all these three B atoms are present in the same plane. So that's why name become trigonal planar. Okay or not? So by this also we are proving it is minimizing the repulsion. Now here I took vector analysis to explain sp2 because one statement given in the coordination chemistry part of the NCERT, कि hybridization is hypothetical. It is the mathematical manipulation of the atomic orbitals or wave functions of the atomic orbitals. Means actually hybridization is mathematics. By doing some maths, we are getting this kind of orbital densities and everything graphs. That is why I took this particular case to explain this statement of the NCERT also, which is given in the coordination chemistry, not in the chemical bonding, कि hybridization is hypothetical and it is the mathematical manipulation. Mathematical, what term they use, that is important. What they are saying, hybridization is hypothetical, it is mathematical manipulation of the wave functions of atomic orbitals. Mathematical manipulation. So tell me, hybridization is real or mathematics? Hybridization is not real. It is simply mathematics. Molecules are real. But the concept which we are using here to explain the structure of molecules like hybridization or overlapping, they are hypothetical. Means theory is hypothetical, but molecules are real. Got the concept or not? Got the concept or not? So hybridization, we can say this also, hybridization is mathematical manipulation only. Chalo, very good. Okay, so this is sp2, trigonal planar geometry is coming. We have 120-degree angle. How many? 3. Got the concept now? How many sp2 present here? 3. Now tell me what is the percentage s character and what is the percentage p character? Tell me quickly. Tell me percentage s character. Tell me percentage s character. Tell me percentage s character. Percentage s character. 33.33, 33.33. Sandeep saying mathematically proof is molecule is real. Theory is not real here. Theory is hypothetical. Okay, 33.333333. Very good. We can calculate easily here. If it is sp2 and I want to find percentage s, I will say how many s present? 1, and total 1 plus 2 3 multiplied by 100. So s is going to be 33.33%. If I want to go for percentage p character, one thing I can do 100 minus 33.33, or I can say total p are 2 and total orbitals are 1 plus 2 3 multiplied by 100 is equal to 66.66. Okay. So now tell me one thing. This s character is coming 33.33. This s character is coming 33.33. This 33.33% s character is present in one hybrid orbital or in each hybrid orbitals. So s character is 33.33. This is present in one hybrid orbital or in each. One or each. One or each. One or each. Just answer one thing. Each. Each. Very good. Gopi is saying 1. Gopi, have you joined late? Gopi, have you joined late? Rahul Kulkarni also giving wrong answer. Others said correct. Each. Very good. Very good. Very good. It means you're knowing the concept. It means you learn the concept. Here this 33.33 percentage we got for s orbital. This is for each. Means this hybrid, the one which is represented by white, this has percentage s is equal to 33.33. This has percentage s is equal to 33.33. And this has percentage s is equal to 33.33. Each hybrid orbital contains 33.33 percentage of the s character, and each one is having 66.66 percentage of the p character. Chalo, move to the next one. Move to the next one. Move to the next one. Next one is sp3. sp3. How many s required and how many p orbitals required? Sir, keep QR after class. Okay, I'll keep it. Don't worry. Okay, sp3 hybridization is written. This heading is written here, sp3. Answer one thing. How many s required and how many p required for this thing? 1 s orbital and 3 p orbitals are required. Okay, so let's say I've taken 2s. Then I will take here 2px, 2py and 2pz belonging to same atom or different atoms? Same atom or different atoms? Same or different? Same or different? Same or different? Answer quickly. Same. Very good, very good, very good. So I will take here 2s orbital, 2px orbital, 2py orbital, and 2pz is perpendicular. So I can represent 2pz. I cannot draw in 3D here. It is 2D board, so I can represent. So I am representing this as 2pz. It is perpendicular actually. So here 2s orbital is taken. 2s orbital, 2px, 2py and 2pz are taken. So 3 atomic orbitals are taken. Now they are going for intermixing and they will give hybrid orbitals. How many hybrid orbitals will form? How many hybrid orbitals are going to form? How many hybrid orbitals are going to form? How many hybrid orbitals are going to form? 4, 4, 4, 4, 4. Very good. 4. As per this example, what will be the name of hybrid orbital? As per this example, what will be the name of hybrid orbital? Name. Now I'm asking name. Number part done. Name. Name of hybrid orbital. 2sp3, 2sp3, 2sp3. Very good. So 2sp3 is the name and this 4 is a number. Okay or not? Now we have to go for the geometrical part. How to arrange 4 sp3 hybrid orbitals so they have minimum repulsion. So here also one mathematics is there, but I will not go in that one because vector addition of 109 degrees 28 minutes is not required in physics and I don't want to explain vector addition here. But in chemistry that is required. So if I am keeping 4 vectors or 4 hybrid orbitals, this is sp3 hybrid orbital, 2sp3 as per the example which was taken, big low plus, small low minus. Okay, another sp3, big low plus, small low minus. Next sp3, big low plus, small low minus. And next sp3, big low plus, small low minus. Okay, and here angle between these sp3 orbitals is going to be 109 degrees 28 minutes for the perfect geometry. Okay, I will represent by the bond here. Let's say central atom is A, surrounding atoms are taken here. This geometry is named as tetrahedral. Standard abbreviation for tetrahedral is TD. Okay. Now I will explain meaning of all these terms which are written here. Okay, so to explain this thing I need few pens, 4 actually, 1, 2. Just give me 1 minute of time. I have to arrange it if it is there or not. Let me check. 1 minute. Okay. Just give me 1 minute. I have to arrange 4 pens to explain this geometry. Just wait. Ravi, give me these 2 pens. Yeah. Okay. Now listen. I want full focus here. Because 109 degrees 28 minutes, everyone is knowing here. But what is important concept that I am going to explain? Sir, is there any molecule which has all bonds present in it? All bonds means all type of bonds. Yeah, possible. We'll discuss, don't worry. Okay, firstly I'll explain tetrahedral here. Listen it carefully. Here, observe please. Yeah, in this way better clarity will come. Yeah, you can check. Assume this is one big lobe of sp3, another big lobe of sp3, next and next. This angle is 109 degree. First of all, I said this is named as tetrahedral. This is named as tetrahedral. Why this name given? So here tetra means 4 and hedral means face. Tetra, you're knowing 4, hedral means a face. This geometry has 4 faces, and that is why name become tetrahedral. This geometry has 4 faces, that is why it is named as tetrahedral. Covalent, ionic and hydrogen bond. Hydrogen bond is not a chemical bond. Okay, first of all, let me focus on this. We'll come to that. Okay, let me complete this first. So, in case of name tetrahedral, first of all, I'm explaining name tetrahedral. Tetra means 4, hedral means a face. 4 faces are there in this geometry, and that is why it is named as a tetrahedral. Sir, how we get 4 faces? Explain us. Don't worry. Let observe here. So this is the representation. This is okay. Yeah, you can check it now. If I connect these 3 corners, I'll draw one face here. These 3 corners are joined. Yeah. Now you can observe. If I join these 3 corners, I'll get one face here. If I join these 3, I'll get another face. If I join these 3, third face, and for bottom, 4th face will come. So how many faces are coming here? 4. Observe again. If I join these 3 corners, one face. If I join these 3 corners, second face. If I join these 3 corners, third face. And if I join these 4 corners of the bottom, 4th face will come. Total 4 faces are present. And that is why name become tetrahedral. Name part I think done. Now the most important discussion. Here angle is 109 degrees 28 minutes. Everyone is knowing. Most of the students are knowing. What better question examiner may ask, ki in this tetrahedral geometry, for example CH4 molecule taken, how many 109 degree 28 minutes angles are present? Angle is 109 degree 28 minutes. My question is, how many 109 degree 28 minute angles are present? Some are saying 6, some are saying 4. 4, 4, 6, 4, 4, 4. Okay, no problem. You will get it easily. Observe again. This is tetrahedral. If I draw angle with this pen or this bond, I can represent 3 angles. 1, 2, and 3. You can observe. 1, 2, and 3. 3 angles I can draw with this. So 3 done. So I will remove this one. So you can easily identify. Now with this one, how many angles I can draw? 1, 2. 3 plus 2, 5. And one more left, 6. I will repeat again. Tetrahedral. With this black one, how many 109 degree angle you can draw? 1, 2, 3. With this one, I can draw 3 angles. 1, 2, and 3. This is done. With this one, how many angles I can draw? 1, 2, 3 plus 2, 5. And this one also left there. This one. So 6. Got the concept now? So what is the best possible question? What is the best possible question here? Ki in case of tetrahedral geometry, bond angle is 109 degrees 28 minutes. Now question is how many? So in case of tetrahedral geometry, bond angle is 109 degrees 28 minutes and total count is 6. Total count is 6. This is the most important question what examiner may ask. Got the concept or not? In case of tetrahedral geometry, how many 109 degree 28 minute bond angles are present? Answer is 6. Got the concept? Because knowing 109 degree 28 minute will not make you topper. Knowing how many 109 degree 28 minute will create difference between average and topper material. Tetrahedral geometry has symmetry or not. It depends on the surrounding atoms. That is the part of chirality, part of the organic chemistry that will be discussed there only. Okay? Got the concept or not? Now, one last question that you will answer. Firstly, answer what is the percentage S character and what is the percentage of P character in sp3. What is percentage S character and what is the percentage of P character? Answer quickly. Percentage S. Answer quickly. 25%. So obviously percentage P is 75%. Now if I give a statement, in case of sp3 hybridization, 25% S character is present only in one hybrid orbital. True or false? 25% only in one hybrid orbital. 25% S character is present only in the one hybrid orbital of sp3. True or false? False, yeah. Each and every hybrid orbital of sp3 is going to have 25% S and 75% P. Here 25% S, 75% P. 25% S, 75% P. 25% S, 75% P. 25% S and 75% of P. And this is directly from the NCERT. Directly from NCERT. Because if I ask you what is the percentage S character in sp3, everyone is knowing here. This will not get difference. If you're knowing this information, each orbital has, each sp3 hybrid orbital has 25% S character, then it will create difference. Let's read this point also. And one more thing, in case of higher hybridizations, sometimes smaller lobes can be ignored also. Like here in sp, both small lobes are represented. You can check in sp2. What happened? Is it hanged, Ravi? Hanged, na? So I need to switch off. One minute. I have to switch off, I think. Just wait. Wait for a few seconds. So in case of sp3, geometry is tetrahedral, Y tetrahedral, Y tetrahedral. In case of sp3, Y tetrahedral, because why name tetrahedral given? Because 4 faces. What is the bond angle there? 109 degrees 28 minutes. How many 109 degree 28 minutes? 6 are there. Now observe here, when they are representing sp2, 3 sp2 hybrid orbitals are drawn here. Big and small lobe both are represented. I said one point, in case of higher hybridization like sp3, sp3d, sp3d2 like that, we can ignore smaller lobes. That's why when they are representing sp3 here, they ignore the smaller one. No problem. That is also correct. Now I want to explain this. I want to read this statement. Let's observe. Yeah. Mixing of one s orbital and 3p orbitals of valence shell to form 4 sp3 hybrid orbitals of equal energies and shape. There is, this line is very important, there is 25% S character, there is 25% S character and 75% P character in each sp3 hybrid orbital. What is important line here? What is very important point here? There is 25% S character, 75% P character in each sp3 hybrid orbital. What is the important part here? Each sp3, this one, each sp3. This is important. Sir, is this class for NEET long-term students? This is for long-term students. This class is for long-term students. Okay? Chalo. So we discussed today. We discussed up to SP3. Remaining part of the hybridization will be discussed in next lecture. If you have any doubt, ask. Otherwise, we can close today's session. Any doubt is there? Yeah, QR code I will share. Don't worry. Okay. Chalo. So for QR. Yeah, where? Oh, sorry. Yeah, let's share it. Okay. Chalo. So you can check QR code here. No problem. जाते जाते सेशन को लाइक कर दो यार. Like, share and subscribe. Okay, no problem. Chalo. So decide quickly as soon as possible. Those who are in borderline, if you are thinking, sir, we will wait for the result. Those who are at the border, wait, but with the preparation. While doing preparation, you have to wait. Don't waste your time. Start your preparation. Okay. If you are getting medical college, you can go there. If obviously fee and everything will be refunded accordingly. If you're not getting, at least your preparation is continued na yaar. So those who want to wait also because they're at borderline, wait, but while doing the preparation. Those who are in the safe zone, congratulations to them. But I'm more concerned about those who are at borderline. Clarities are not there, they will get medical medical college or not. For them, my suggestion is start a preparation, select the right class where they're dealing with the concept, where they're explaining the concept, not making jokes. And if you're getting college, you can go. If not getting, your preparation is going well. So you're prepared for next year. Next year you may get aims. And those who are getting low marks, they're knowing I'm not going to get medical college. So don't live in hope. Sometimes hope destroys our future. So if you are getting very low, so don't live in hope ki if cutoff will go 200, then I will be selected. Don't think in this way. Just start your preparation. Na yaar. If you are getting medical college, you can go there, no problem. And take proper and wise decision. Chalo. Okay. Bye-bye. Take care. All the best.